Hi, in this video I will go over contains duplicate. So given this problem statement, we're given an integer array called nums, and then we want to return true if any value in this array appears at least twice, and then we're going to return false if every other element is distinct. For example, let's look at array with 1, 2, 3, 1. In this case, we are going to return true since the value 1 in this array appears 2 times. So we're going to make sure to and if an element appears 2 or more times, right? If it only appears 1 time, then it's unique. Otherwise, we return true. So it's a pretty straightforward problem, and I will get started with my approach. First thing I like to do is analyze the input and think about what the output is going to be. So for our input, we are given an integer array, and output will be a boolean. Right, so given this information, what can we tell about the input? Well, it's not going to be sorted, but let's think about what if it was sorted? Will that help us with finding the solution? Well, we could take that approach and then basically let's take an example for that. Let's say we had the same example, right? So 1, 2, 3, 1. But then now if it's sorted, then we have 1, 1, 2, 3, right? So this seems to be like faster because after just the second iteration through this array, we have detected the duplicate and then we can return. However, if you take another example where we had 1, 2, 3, and then 4, 4. Now, although this is sorted, it's still going to have to iterate through the whole array or algorithm, and it'll take the same amount of time. So really sorting the input wouldn't really help us. So this was just like a part of analyzing the approach and some thoughts about the problem. So yeah, so here we thought about sorting. And then the next step that I like to do is think about edge cases and constraints. So we are given this integer array, but what if we had an empty array? Well, then we don't have any duplicates, right? So we're going to assume it's going to be false if in the empty case, right? So empty will be false, and then also going to assume that the array is going to consist of negative to positive ints only. And yeah, in the problem statement, we are guaranteed it's going to be at least one element in the array. So the length is going to be at least 1, which is good. So we don't have to worry about this case. But it's good to think about it in an interview. So the next step is I like to come up with a brute force solution. Well, in this case, so the brute force solution would be basically going through every element in the array. Let's see this example again. So 1, 2, 3, 1. So we can have like a for loop that would iterate through every element, and then a nested for loop where we would do the comparison, right? So let's say we start at this element in our outer for loop, and then we compare it with the rest of the following elements. In this case, we have found a duplicate, and this would return true. However, thinking about this, our time complexity would be big O of n squared, since in the worst case, we're going to have to go through every element and all the other elements. So in this case, we have n, and then another n, and then another n, and then, if that makes sense, right, it's going to be n by n, which is n squared. So we can come up with a more optimal approach. Let's think about what would be more optimal solution in terms of like time complexity. In this case, time is, this is for time, right? Okay, so another case, or another approach to this problem would be using some sort of like a data structure where we could store the elements and then basically keep track of their frequency. If you know, like maps, they have like key value pairs. So our key could be like the element, and then the value would be the frequency. So in this case, 1 would have a frequency 2. And then after we add all these elements and their frequency, we can do that in one pass, right? So we take this element, we add it to the map, we add this element, we add it to the map, and so on. That would eventually add all the elements and their frequencies, and then we can do another pass on the values of the keys, right? And then if it's greater than 1, we basically return true and false. And this would be, our optimal approach would be big O of n time, and then big O of n space, right? And then, yeah, after that, I'll just make sure that it works. So I will go through a test case. All right, let's pick a different test case for this one. Say we have, let's see, so say we have 4, 7, 9, 3, and then 4, 2, right? So what I'm going to do is actually just have a set. A set would, so the thing about sets, it's only unique keys, right? So if you try to insert a key into the set, it just ignores it and it doesn't add it to the set. So as we're going through this in our first pass, right? So we see 4, we check if it's in the set. Here, unique keys inside the set. Right, so let's say we have a set here. It's initially empty, right? And then as we're going here, okay, we check, is 4 in the set? No, it's not. So then we basically add 4 in here. And so on. So is 7 in the set? No, we add it. Is 9 in the set? No, we add it. Is 3 in the set? No, we add it. And then we're at 4 now. And then we're checking, is 4 in the set? Then yes, it is. So we basically just return false at this point, and our algorithm terminates. I think this is better than the map approach because we don't really have to add all the numbers or their frequencies really. So this is just in one pass we're adding the element, or either adding it to the set or just returning false if it already exists in the set. So this is a run of the code here. So in C++, this was the function we have. So it returns a Boolean, and it takes in a vector of integers called nums. This is what we discussed in the input-output at the beginning of the problem. Yeah. So first thing here I did is initialize an unordered set of integers. And we know that in unordered set, the lookup time is just big O of 1. So this is going to be good. And then we have a for loop. So this is our one pass where we do everything. The loop starts from 0 up until not including the size of the list. So in this case, we had what is the size of the list? So we had 6 elements, right? So it's going to have 5 iterations in the worst case. And then in this condition, we're basically checking if the set has this element at the ith index in nums, right? This is nums, our integer array. And then if it's not equal to end, meaning that it exists, right? Because in C++, if you use this find function and it's equal to the end of the set, this means the element was not found. So if it's not equal to the set, meaning it exists, we return true, meaning that we have a duplicate. Otherwise, we insert the integer at the ith index into the set, and after if this algorithm runs during its all its iterations and doesn't return true, well, we just return false at the end, meaning the element was not found and we don't have any duplicates.